Welcome to part one of the ReGenX generator demonstration video. Here we have a conventional generator, and in part one we're going to explain conventional generator armature reaction, otherwise known as regenerative braking in an electric vehicle. What generator armature reaction really is and how it manifests. So in an electric generator, there is a prime mover that delivers the mechanical input power to the generator. The prime mover can be an internal combustion engine, it can be wind, it can be hydroelectric mechanical power, or it can be the inertia of an electric vehicle. So on no load, when the generator is being turned by the prime mover, in this case, actually I'll do it in the clockwise direction. When the generator is being turned in the clockwise direction on no load, you can see that it's very easy to turn the generator. There's some mechanical power that's required, but it's minimal. Now, when the generator is placed on load, as I'll do here, when the generator is placed on load, current flows from the generator to the load, and a magnetic field is established around the load current, the current bearing wire. A magnetic field is established around the generator coils inside the generator, and the magnetic field produced around the generator coils creates a counter electromagnetic torque, which is actually trying to turn the generator in the opposite direction. So if our generator is being idled by our prime mover in the clockwise direction, and when placed on load, the magnetic fields produced around the coils inside the generator create a torque that's turning in the counterclockwise direction. Now, we're delivering about maybe 0.3, 0.8, it jumps up and down, but it's extremely hard to turn the generator when you're working against the counter electromotive torque. Now the counter electromotive torque produced by the conventional generator is a function of the magnitude of the load current. So the greater the load current, the more the stronger the magnetic fields produced inside the generator, and the more counter torque is created. Now the ReGenX generator differs in its operation in that when the ReGenX generator, and you're going to see that in part two and part four, I guess. What you're going to see is when the ReGenX generator is placed on load, instead of creating a counter torque which resists the prime movers or the direction of mechanical energy in the drive shaft, the ReGenX generator produces a complementary electromotive torque which goes in the same direction. So when the ReGenX generator is placed on load, the ReGenX generator makes it easier for the prime mover to turn the generator, it's easier than when it was on no load. So we're going to show that in the next video.